cell phone world, where so there's software from, and I forget who it was. I saw one of the edge hacking talks here Quest. A couple of years ago. Yeah, I think Quest is the one that they make a piece of software that'll let you reprogram certain types of 3G cards, right? So you get the software, and it's totally illegal to have. I mean, it's like proprietary internal software that like only their techs are supposed to have.
It's class 1. Right. It's not class 2, I think.
Well, yeah, and it's not supposed to be out there, but of course it is, right? You can download it like on any torrent site out there and then reprogram this stuff and pretend that you're a tech, right? Well, so in this case you have hardware that also matches that, but it's kind of naive to think that software is not going to get out eventually, right? That when somebody figures out what you can do with this stuff, and that hey, this is actually kind of valuable, and that there's I just need to like steal a CD in a box off this guy's truck. I mean, it's entirely a different world. Again, and like I said, there were protections built into the software of, like functions that were hidden, and there's the user login stuff and all this. But I mean, it's trivial to reverse engineer. And I'm not an advanced RE, and I did it in about 15 minutes. And so I mean, it's the same problem of you've got people that are stepping into a very difficult world where they're trying to protect pieces of information when you have full control of it. Right, and it's like the Sony PlayStation problem or something like that. But these guys have been doing it for 5 years, not like 20.
So kind of along. So we talked about AMI for a while, and we're pretty much going to forget about AMI at this point. So I kind of have this thing of fuck meters. Meters are cute. They're cuddly. They're really super. And worms going around. Meters. Cats and dogs living together. It's bad stuff, right? But at the end of the day, that's not smart grid. That's the grid, right? Is the whole spiel, right? The whole shoot and match. AMI is just the first wave, and one of the reasons for that is that it doesn't have a lot of footprint now, right? So that stuff's not wired up. There's a big consumer benefit. There's a lot of things that the consumers see out of it, and of course, obviously, it's a push to get real time data, billing data, and be able to see that stuff in real time instead of a dude walking to your house once a month, right? But the longer term picture here is not about just the AMI side. It's about the actual backside here, distribution automation and energy management systems and all of that. And a lot of the motivation here, the green stuff and all of that has really come about in the last couple of years. The vendors in this space for years have been pushing this to utilities. Prior to that, they didn't call it green energy. What they talked about was that this gave you demand response in real time and data gathering in real time. The reason that you do that, if you remember a little company called Enron that kind of sold power short, right? They kind of sold it a little short, oops, and kind of took, say, a state offline for a while, oops. A lot of that comes down to the fact that their data gathering and what they had was at monthly increments. That's how they're predicting this.
And a lot of you guys probably run networks, right? So imagine if you were trying to deal with what your bandwidth demand would be, but you had like no idea how much bandwidth was being used, right? Like you had some
Comcast.
very rough signposts, like once a month or something, you found out that, we use this much. So you would buy a whole lot extra, and you just hope that you didn't run out. Right? So that's kind of where it is right now. But this stuff is going to give you highly detailed information, maybe every 15 minutes, maybe every hour, but you're going to be able to have very highly specific info on how much energy is being used in a given part of your area.
Yeah, and so right now, basically the way it works is you essentially overbuy on capacity or you're hosed. I mean, that's pretty much
yeah, if you don't overbuy,
if you don't overbuy, bad stuff happens, right? So when you can see those curves and you can predict it a lot more, what then happens is that, and yes, at the end of the day, that means that we're going to use less, electricity because we're going to have better data. But it also means that the utilities trading markets become more like NASDAQ, more like real time, and so that stuff can move around a lot faster. That means profit for everybody, right? So that's really where a lot of this stuff came from, and then the green stuff kind of came after the fact. So yeah, at the end of the day, what that means in order for that to work is that somewhere power on the grid, decisions about what's going to happen to it are being made in software.
Right, and then all that's being implemented over RF down to lots of little devices all over a city or a given state, and these little switches that flip on and off and move power around, right? And what we found is that all of that, or the majority of that, is happening over RF in our experience.
And meters are freaking cute. Right. So, that was kind of our conclusion. We looked at a bunch of meter stuff for somebody, and we're looking at some of that. And well, can you look at we have these other things we probably should talk to you about, And so what did they do? And oh, you know, substations, you know, plant control, nothing, you know, nothing really important. And the deal with that, and that's, yeah, actually I think we have some of this on this next slide. The deal with that is that that's stuff you don't fuck with. Okay, so you take neighborhoods to offline. Dude knocked on your door if you've got, you know, new meters lately, and it happened to me. I said, no, come back. I'm working on a dock. You can't take my network off, you know. But it came by and said, hey, I'm just gonna take your power off. I'm doing something, you know, or whatever, for 5 minutes, and he pulled the meter and popped it back in, right? And then poof, you're on new tech, all new stuff. You can't do that with a recloser. You can't do that with a substation, okay? So what happens is you take the existing stuff that's out there, which is modem lines, serial. Some of it is things that you have to physically walk up to, and you bolt something onto it. And yeah, these things are typically, they're already networked in some way, and now it's about, let's get all that stuff up, just like the meters, and let's get it up in real time and have a real network. So, yeah, and in a lot of cases, that's going to be via something like WiMAX, it's going to be cellular. And in a lot of cases, the vendors that sell the meters are selling the back-end tech too, and that's a selling point. It interoperates with your meter tech. It's all the same gear.
Yeah, so you've already spent this money on infrastructure to have this, you know, blanket network, this fancy mesh stuff everywhere, and now, oh well, so this is the same thing, right? So I can take advantage of that, and I just plug on an extra NIC to that, and I'm done. Right?
Yeah, and in some cases, we've seen that actually mean that there are literally Ethernet drops in boxes and on poles. So you have a device that was previously on a nailed circuit over, you know, something that mapped out to, you know, there's a router hanging off, there's something that mapped out to, you know, came Ethernet off of there, and that's just getting plugged into some wireless device. And literally up on a pole or with one of those same cute little locks that you have on your meter outside.
Yeah, all these devices that you would use to retrofit old tech like that, they're basically RF with either a serial interface or like a Cat5 cable, right? And so you'll start looking around, you'll see see the little, oh, that's a Cat5 cable on that, like right there. That, I wonder what happens if I were to tap into that, right? And you talk to people about, well, so what are the kind of security around these things? And you know, it's this type of deal, and yeah, there's a fence, and yeah, there's maybe a camera, and then they tell you things like, well, yeah, I mean, it's in a secure location, but we've got this huge problem. People keep breaking in and stealing all our copper, right? And so you're like, well, okay, so I recognize that there is a fence, but I also recognize that apparently you have a problem with people regularly breaking into this environment, and you can't really stop them. So. Right, what does that mean with this stuff, right? Where it literally is a network cable, and hey, I could put like a vampire tap on that, or I could just unplug it and plug myself in. Where does that drop you? What does that give you? In some cases, it drops you on a subnet with a whole bunch of these other devices, right?
Which all talk again, SCADA over IP via known protocols that in some cases may or may not have any other controls around the communication. And actually, larger point, if you work for a utility, like really simple, guys. IPsec is your friend. We use it on the internet. We like it. We've used it for a long time. Seems to work pretty good. So put that on that stuff. And there are vendors that do that. If you're going to take your Ethernet drop or your SCADA and everything and hang that over some long-range FHSS radio or WiMAX, whatever the hell it is, put IPsec on it first. And if I break that protocol on the wireless end, I'm still just going to see IPsec traffic.
Right. Or if I get on that network, all I'm going to see is an IPsec endpoint. And yeah, so you've got this, those are all over the internet, and we feel relatively confident about those.
Yeah, they're not fantastic. I mean, don't get me wrong, I'm not going to defend IPsec, but it's better than what we're seeing. And just another example, that's a recloser. So these devices, and they usually have, like, say, actually modems or GPRS or something hanging off them now. These are essentially circuit breakers. So when your load changes, you have an outage that, say, lightning strike or something else, this is going to essentially just flip a really big stinking breaker, okay? And it's going to move power over one direction or the other. 10 minutes.
So we've spent a lot of time talking about, so how all this stuff works, how it's put together. We've talked about some of the hardware ways to tap into these networks, right? Literally unplugging stuff, hooking in, tapping on specific places on like a board or something like that. But we'll probably, we've got 10 minutes left, so we'll go ahead and switch over and just start talking about
some of the things that we use to connect to this stuff. Yeah. So Zigbee, we're not going to go into a ton of detail about it. Josh Wright is awesome. We love Josh. We'll buy him beer. The Zigbee stack historically, in order to interact with Zigbee, you had to buy essentially these developer testbed kits that Digi makes. They're called XB, and they're relatively expensive, a couple $100. With Killer Bee, you can buy Atmel cards that are about $40. You need a JTAG that you can write a custom firmware to it, but it's pretty straightforward to do. Basically, what that gives you the ability to do then is the same kind of thing you do with wireless, where you can do injection, you can sniff, you can go into, you can monitor traffic and things, and so this gives you the ability to interact with Zigbee gear a fair bit. So it's neat stuff.
With specific application to smart grid, it does not support the SEP stack. So there's a I don't know how much you know about Zigbee, just real quick. It has these different profiles that kind of block into it, and it hooks down lower, and it sets certain configuration parameters, stuff like that. There's those set for smart energy. So his stack does not actually talk smart energy, so you are somewhat limited in what you can do with his stack. You can also go out and buy like a stack from it was XB or some of those guys for like $200 or $300, and then you have a full SDK that will allow you to build applications that will interact with that network. So.
Yeah, and actually there's so like we said, Zigbee's kind of reduced 802.11. We're all used to like layer 7 model. So Zigbee is kind of, you've got a real basic network layer that's like a much simpler network stack than what you would see in, say, something that's full 802.11 or like wired Ethernet or something. The larger point about Zigbee is we talk about Zigbee itself a lot as being sort of intrinsically bad. It's not fantastic, don't get me wrong. But SEP, the smart energy profile that the utilities use, does add a lot of extra security bits on top of it.
There's been problems with Zigbee in the past with say like over-the-air key retrieval and stuff, where when they first hook up, it'll actually transmit its encryption key, clear text. Well, as an example, SEP says no, you can't do that. Like you are not allowed to do that in this environment. Yeah. And so that key management stuff all has to happen outside, in an out-of-band process. So that's one example of ways that it actually locks down the sort of default Zigbee protocol.
Yeah.
And so overall point with Zigbee is just that we actually kind of like it. As far as comparing it to what your other options are, it's been looked at by a lot of really smart people, and it's
by no means fantastic, but if we're grading on a curve compared to the other stuff we see, it's not so bad. So something else, and we talked a lot about this. Something that and I know that there's somebody else that's doing some talk about some of these things. The FHSS frequency hopping spread spectrum is what those substations and reclosers and things, what we see a lot of that stuff running on. This is a technology from World War II. It was based on the concept that back then radios were difficult to tune. You had to solder a new crystal on, essentially to get wider bands and stuff. So it's meant for there's some other good reasons, and things like interference with radar and all this other stuff that you want to hop channels, and it does give you longer range and a lot of other good stuff. But the security argument for it is that you have to be able to follow the hops on an FHSS radio.
And it's funny, if you go actually to the Wikipedia entry for FHSS, you'll see a bullet point that says FHSS provides security. Like that it's a selling point of FHSS, and that it's hard for you to do narrowband interception and like listen and know what channel it's going to be on.
All of you go edit that entry when you get back to your rooms.
Exactly. But so how do you fix that, right? Well, just do wideband interception, right? Listen on a band that's wide enough that you can see every single channel, and then it's irrelevant where it's hopping, right? And you can watch that long enough, and you can figure out the pattern. And most of these guys, their algorithms will repeat themselves. So then you can just learn what the pattern is, and then you know what that pattern is always for that device that's talking to this other device. Right?
And the wideband interception capability didn't really come about till pretty recently for that to be easily accessible to people. That's where the USRP, anybody went to Chris Badge's talk, knows all about that stuff. The USRP2 gives you a much wider band that you can sample off of. So previous stuff that people have done against FHSS with that device, with the older version of the device, had to like watch one side and then the other side. With the USRP2, you can pull enough that we can just see all the samples.
We're pretty much out of time. Do we want to?
Yeah, we won't say a whole lot about the USRP or GNU Radio, which is the API to write to that.
Just
go check it out.
I would say about GNU Radio, it's got a fantastic API that'll let you do a whole bunch of stuff.
A fantastic yet horribly documented API.
Yeah, and don't ask any questions on like IRC or on the mailing list, or you'll just get slapped.
Yeah, they'll just beat you if you don't have a PhD in EE.
Right. Did you not go read the docs, like the big like EE book, right?